Guys, welcome back to our channel Automation is Future. So in today's video or in this video we are going to see about another most important component which is used to like restrict the flow or direction of flow which is going into the cylinders for reciprocating movement or rotary movement of our actuators. So we call this component as direction control valves. So already, if some of you might have already heard about direction control valves, majorly we will be naming them as 3 by 2 walls, 4 by 2 walls, 5 by 2 walls, or 5 by 3 walls, 4 by 3 walls in this way. So let us try to understand what is 5 by 2 or 3 by 2, what how those names has came. So let us see. So first number in any component, first number indicates number of connections or number of ports, and the second number indicates number of positions. So now let us see what is port and what is position. So firstly, if we have a box, one square box, we call it as a position. So if we have two square boxes, we call two positions. So the second number. If I have three square boxes, I call as three position. One position, two position, and three position. So in this way, we will be determining. So inside this position, if there is any lines, these indicates the flow path. They might be from top to bottom, bottom to top, left to right, or right to left, or diagonally also sometimes. So this is flow path. So in this flow path only we can see there is an arrow indicator, so which will show us the flow direction. An arrow indicator which will show us the flow direction. These arrows might change time to time depending upon the flow of the air. And then we have restricted flow also. Sometimes there might be no flow. So restricted flow, which is indicated with T section. So here you can see, we can say in this first position there is flow, in the second position there is no flow. That way. And sometimes we will be having two connections where one at one connection there will be flow and at the other connection there will be no flow. And we have the outer lines. Whatever the outer lines are there, all of them are called as ports, number of connection ports, where we would be connecting air pressure pipes to the system, where we would be connecting the outer air pressure pipes to the system. So this is about this thing. So if I have single box, I call single position. Double box, I will be calling two positions. Number of connections, I will be calling 4, 3. So port. So here, based on this, I can say this as 4 by 1 wall or 4 by 1 direction control wall. So based on this, all the other components we can identify. So now the first DCV which we needed is, we have these DCVs are designed based upon the actuators. So these DCVs are designed based upon the actuators working. So in that, firstly we have single acting cylinder. So for that single acting cylinder, I need to control only one direction of flow. For that reason, they had designed a component. So which is nothing but, here we can see by the diagram we have two connections. So it is two and two square boxes, which means two positions, two port connections, and two switching positions, which is nothing but 2 by 2 component. So I need to send the air pressure and I need to restrict the air pressure. So for that reason, they had designed 2 by 2. And over the time period, they found that 2 by 2 is not ideal component for working off or making a single acting cylinder to run. So they have designed the another component which is called as 3 by 2. So why 3 by 2 means, so whatever the air going, just let us assume there is a single acting cylinder with spring. So if I am connecting air pressure, sending air at this point, what happens? Whatever the air goes into the cylinder, and when I shut down the airflow, what happens? The positions changes. So what happens? This become close, and whatever the air filled inside the cylinder, that will not come outwards, or it will take more time for escaping of the air. So for that reason, they had made a small hole on the other side of the component to release the extra air. So this is three connections. Top we have one, and bottom we have the another two. So we call this as 3 by 2 wall. In present days, 2 by 2s are not used anymore. We are using 3 by 2s for single acting cylinders. So, in this way, in the component also, we have one more term whether we need to how to identify whether the component is open or closed. The component is called as open component whenever the flow is coming outside. If the flow is coming outside, or the arrow direction, whatever the arrow direction is there, it is showing to the top, so we call it as open position component. If the arrow direction is not showing top, which as in our second diagram, it means closed position. Okay, so we have sometimes we'll be using open position components and sometimes we'll be using closed position components depending upon the type of application we will be using. We can use 2 by 2 normally open component, 3 by 2 normally open component, or 3 by 2 normally closed component. So let us see how it actually works in animated video. So here you can see 3 by 2, this is closed position component. So we are giving air supply from the compressor, and this air supply is being stuck at this point only. And whenever we are pressing the push button, what happens? The spring is getting pressed, and this air is going from the top of the spring, and it is getting released into the output or outwards. So we call this as activation. We had activated it, and there is stream of airflow is going out. Now we have this the other component. I have said like a couple of seconds back, I have said that we will be there is a hole made in the 2 by 2. So if you observe in normal, when there is no activation, you can see light blue color 2 and 3 are connected. So whatever the air, extra air which is non-pressurized, it will come outwards from 2 to 3. So let us see how it works in the this thing. Here you can see we have a simple sequence of operation has been connected. So here we have a single acting cylinder, a 3 by 2, and as usually needed pressure source or air pressure source compressor. And for regulating the air pressure source, we have an FRL unit. So from compressor to FRL, we will be connecting FRL to our 3 by 2 component and component to my single acting cylinder. Whenever I press the push button, what happens? Air flows, cylinder moves forward, and whatever the air is there, if there is no activation in the push button, the spring will push it backwards, and this air comes from 2 to 3, and from 3 we will be releasing into atmosphere. So this is how we will be using a 3 by 2 3 by 2 open position valve for working of single acting cylinder. I hope you guys got an idea. So thank you guys. Thank you for watching my video. Don't forget to like, share, and subscribe to Automation is Future. Thank you guys.